Okay. Simple trigonometric equations. Let's straight away jump to the questions. Exercise 6D. The diagram shows sketch of y is equals to tan x. On the right, use your calculator to find the principal solution of the equation tan x is equals to -2. So we always go for positive values first. Suppose this is tan x is equals to -2, but to find the basic angle alpha, I'm doing tan inverse of 2. And using calculator, so shift tan of 2, I'm getting 63.4 degrees. 63.4 degrees. And tan inverse of -2 would give me the same on the opposite side. It gives me -63.4. So at -2 I'm getting -63.4 degrees. B part says use the graph and your answer to part A to find the solution to the equation tan x is equals to -2. Now if I just look at this tan x equal to -2, we can see that we have more options from 0 to 360. This complete line I'm having two intersection points, 1 and 2nd. And in both of these points you can see it is more than 90 and more than 270. It is better to understand when we draw the coordinates. So tan is negative. We knew that. Add sugar to coffee. So tan must be negative in the second quadrant and in the fourth quadrant. And from the graph, see that this first is in the second quadrant, that is more than 90 and less than 180. Then this next angle is more than 270 and is less than 360. So again in the third quadrant. So this is the basic angle, which is 63.4. So that is 63.4 less than 180, leaving me with an answer of 116.6. So this is 116.6 degrees and the other one is 63.4 less than 360. That is 296.6 degrees. Question number 2 says the diagram shows a sketch of y is equals to cos x. Use your calculator to find the principal solution to the equation cos x is equals to 0.4. So I'm doing cos inverse of 0.4 to find the first basic angle. We represent that with alpha. So cos inverse of 0.4 is giving me 66.4 up to 1 decimal place. So 66.4, and I just saw it is in radians. Let me change that. So changing the mode of calculator and in radians. So shift cos of 0.4 gives me 1.159. This was degrees, and in radians it is 1.159, approximately equal to 1.16 radians. We'll deal with this as we are given with radians. B part says use the graph and your answer to part A to find the solution of the equation cos x is equals to 0.4 plus minus both. So if I just mark here as 0.4, I already know the first angle. So we know this is 1 and this is 2 up till 2 pi. So this is the point up till 2 pi. I'm not going beyond that. So we need these two angles. First angle is already there, which is 1.16. And for better understanding, add sugar to coffee. Cos positive, negative. So we need both angles, all four angles. So 1, 2, 3, 4. And negative 0.4 to represent it on graph will look like this. So we have these four angles marked. Now this is 1.16, 1.16 in all four coordinates, 1.16 and 1.16. So the first angle is straight away 1.16 right here. And the second angle is 1.16 less than pi. So in calculator, pi minus 1.16, I'm getting 1.98. The second angle is 1.98. 0.98. Now the third angle is 1.16 more than pi. That gives me 4.30. So this third angle is 4.30, and this fourth one is 1.16 less than 2 pi. I'm getting 5.12. So all four angles for this is 1.16 radians, 1.98 radians, and 4.30 radians, and 5.12 radian. If we just plug in these values in place of x, we will get either 0.4 or negative 0.4. Question 3 says solve the following equations for theta for 0 to 360. Now let's try a few of them. Let's say we solve each part. So this is sine theta is equals to negative 0.766. We always find basic angle with the positive value. So sine inverse of 0.766, and this time it is in degrees. Changing the mode in degrees and shift sine of 0.766. I'm getting 49.996, so that is almost 50 degrees. Now 50 degrees, but I know that it was negative. Sine theta equals a negative value, so it should be in the third and fourth quadrant. So this right here is 50 and this is 50. So our first angle is this complete line, which is 180 plus 50, giving us 230. So first angle 230, and the second is 50 less than 360, so that is 310. Now let's try this C part. Cos theta equals 1 by 2. So cos theta is equals to 1 by 2. That is already positive. Cos inverse of 1 by 2. So I'm getting the basic angle. Shift cos of 1 by 2. That is 60 degrees. And it is positive. So we know it would be in first and last quadrant. Add sugar to coffee. So first and last quadrant. So this is straight away 60 degrees is the first angle. And the last one is 60 less than 360, which makes it 300 degrees. So question number 6, we see that square root of 3 sine theta is equals to cos theta. Now I'm dividing this on left hand side. So sine theta divided by cos theta, and I'm taking square root 3 on the other side. We know that sine theta over cos theta is tan theta. So tan theta is equals to 1 by square root 3. Now finding the basic angle, that is tan inverse. Now all these steps are same as we did in question number 3. So basic angle is, and it is in radians this time. So changing the mode of calculator in radians and shift tan of 1 by square root 3, getting pi by 6. Pi by 6 is the basic angle. This is where I knew that I have to do it in radians. So, and before we solve, tan theta was equal to positive something. So add sugar to coffee, either the first or the third quadrant. So this first angle is pi by 6, and this would be pi plus pi by 6. Pi is equals to 180 degrees. So pi plus pi by 6 makes it 7 by 6 pi. So the first angle for theta is equals to pi by 6, and the second is 7 by 6 pi. Look at this B part. So cos theta plus sine theta plus cos theta is equals to 0. I'm taking 1 on the other side. So sine theta is equal to minus cos theta, and I'm dividing with cos theta on left hand side and leaving minus 1 there, is equal to minus 1. Now this is tan theta is equals to minus 1. So I'm doing shift tan of 1 to find the basic angle, which is pi by 4. So alpha is equals to pi by 4, and again we do this the same triangle, and we know that we are required of negative angle. So second and third. This is pi by 4. This is pi by 4. So first one would be this complete angle theta, which is pi by 4 less than pi. That comes out to be 3 by 4 pi. So theta is equals to 3 by 4 pi first angle, and second is 1 by 4 less than 2 pi, leaving us with 7 by 4 of pi. Clear? Find the value of theta, question number 2a, from 0 to 2 pi. See that this is 2 theta already. So I should have domain for 2 theta. So I'm changing this, multiplying the whole equation with 2. This is 0 less than equal to 2 theta is less than equal to 4 pi. So I'm solving this. I'm considering that for the ease of writing, I'm writing y in this place. So I can write 0 is less than equal to y is less than equal to 4 pi. So cos of y is equals to 1 by 2. Basic angle for y should be cos inverse of 1 by 2, and calculator should be in radians mode. So that is shift cos of 0.5 gives me pi by 3. So basic angle is pi by 3. Now I'm looking for y. So pi by 3, that is already positive. Cos is positive in first and last, and because of this 4 pi, we know we have to make 2 round shifts. So this first is pi by 3. I'm writing it here, pi by 3. These are all y. Second one is this angle, which is pi by 3 less than 2 pi. That is 5 by 3 of pi. And then another shift when we move forward again, this is 2 pi plus pi by 3, giving me 7 by 3 of pi. And last one is pi by 3 less than 2 pi, less than 4 pi, which is 11 by 3. Now we knew that 2 theta was equal to y. So 2 theta is equals to y. Theta would be y divided by 2. So theta is equals to every angle divided by 2 is pi by 6, 5 by 6 pi, 7 by 6 pi, and 11 by 6 pi. So these are the 4 angles for cos 2 theta is equals to 1 by 2 for the given domain. And see, all of these angles are within 0 and 2 pi.